Okay, so in this video we're going to discuss about long division. Okay, so this involves cubic polynomial. Okay, so how do we know it's a cubic polynomial? You're going to see the highest degree of x is 3. Okay, highest degree of x is 3. Okay, so let's see question number 1. Find the quotient obtained in dividing a x cubed plus 2x squared minus x minus 2. Okay, so we're just going to copy the question. X cubed plus 2x squared minus x minus 2 divided by x plus 1. Okay, now first thing, before you do your long division, you need to make sure that your degree and your power kena decreasing. You see 3, 2, 1 and this is actually x equals to 0. See, it's decreasing. 3, 2, 1, 0. Okay, so no need to write x power of 0. Okay, now kalau the degree is decreasing, barulah you are ready to do long division. Okay, so our mission is to eliminate all the big power. Okay, so first thing first, I just follow this method. Okay, we are going to eliminate x cubed using the divider here. Okay, just focus on the x and x. Okay, so now just copy back x power of 3 divided by x will become 3 minus 1, so x squared. Okay, so we have to place it on top of the same power, meaning kalau x squared, put it here, put the quotient on top of the same power. See, x squared and x squared. Okay, now x squared times x cubed, x squared times 1 plus x squared minus, okay, x cubed no more, and then 2 minus 1, you will get 1. So just put x squared, bring down negative x, and then do the same thing. We want to eliminate x squared pula, x squared. Okay, so it will become x squared divided by x. Mana dapat x, you wondering? Ni okay, so you will get 2 minus 1. 2 minus 1 is 1, so x power of 1. So just put here x power of 1. Now do the same thing, x times x squared, x times 1, just x, then negative 1 minus 1, negative 2, negative 2x, negative 2. Okay, again we want to eliminate negative 2x using x, so negative 2x divided by x, check, become negative 2, so negative 2 here, negative 2, again negative 2 times x, negative 2x, negative 2 times 1, negative 2. Okay, so negative 2 plus 2 becomes 0 and also 0 here. Okay, so our quotient is x squared plus x minus 2. Okay, let's see question B. Okay, this is a bit different. As you can see, the arrangement is different from question A. Okay, so let's just copy the question dulu. 20 plus x plus 3x squared plus x cubed. Okay, now as you can see, we have to make sure that the degree is decreasing kan, but now instead they're increasing kan. 1, 2, 3 is 0, that's x power of 0 kan, so you need to arrange dulu. Okay, so let's rearrange the polynomial. X power of 3, 3x power of 2 plus x plus 20 divided by x plus 4. Okay, barulah you boleh perform your long division. Do arrange power in decreasing order. Okay. Alright, then again x and x cube divided by x, 3 minus 1, so x power of 2. Okay, x power of 2, then x power of 2 times x cube plus x power of 2 times 4, 4x squared. Then 3 minus 4, negative 1. Okay, negative 1, don't put 1, just put negative x squared. Then bring the x down, and then you're going to eliminate yang x squared plus negative x squared divided by x. Tinggal negative x, so negative x times x, negative x squared, negative x times 4 plus minus 4x. Okay. Then 1 minus negative 4, 1 plus 4 lah. 1 plus 4 is 5. Okay. Positive 5x. Bring 20 down. Then going to do same thing, x cancel, you get 5 plus 5. So here 5 times x, 5x, and then 5 times 4, 20. Okay, so your quotient is x squared minus x plus 5. Okay. Okay, let's see question number 2. Okay, this is a bit different from the first one. Okay, question asks for find the quotient and remainder obtained in dividing. So the difference between the first one and this question is, okay, later you'll see some remainder. Okay, a recap from our first lesson again. You can see that in the end we don't have any remainder. Remainder is the number at the end of the long division. See, we get 0, 0, 0, 0. Okay. So now you are expecting some value lah, ada value. Not a value, I would say a polynomial, a linear. Okay, a linear, and then okay, let's get started. A x plus 5, and then x cubed plus x squared plus 17x plus 16. Okay, now let's go do it. Dah boleh dah kan, laju kan. So it's x cubed over x, so x squared here, x squared multiplied by x cubed, and then you will get 5x squared minus 0, 8 minus 5, 3x squared, bring down 17x, and then 3x squared divided by x, check 3x plus 3x squared, 15x, 17 minus 15, 2x, bring down 16, 2x divided by x, you will get 2 plus 2, 2x, then 16 minus 10, you will get 6, so remainder is 6. Quotient is x squared plus 3x plus 2, remainder is 6. Okay, so question B. Okay, so now we see some power kan, power, and this one got no power, bukan no power tau, tapi x dia power of 0. Okay, let's copy this question B. Question B, 3x cubed cube kan, plus 4x squared plus 7. Okay, before you proceed with the long division, okay, you must rewrite the equation. 3x cubed plus 4x squared. Now we can see that x power of 1 is not in the equation kan, so you have to create some value. 0 lah, 0. Okay, 0x power of 1 plus 7. Okay, divide by plus 2 plus x, or you could write as x plus 2, same thing. Okay, okay, now why do we have to do this? Why do we need to show that the x is in decreasing power kan? Because later it's easy for you to arrange lah where to put your quotient on top of the power. Okay, that's why you need to create a value. Okay, now do the same thing. Okay, and then you can pause this video and then you can check with the answer. In the end, you will get the quotient is 3x squared minus 2x plus 4, and the remainder would be negative 1. Okay, you can try. Okay, just now we can see from the two questions that we did, I mean the first one, which we have no remainder after we did the long division, and the second version is we have some remainder here. Okay, so let me copy both of this question dulu. Okay, let's see. When we compare these two division, on the left we can see we have no remainder. Okay, so this brings us to the next topic that we're going to discuss, which is the factor and remainder theorem. Okay, factor and remainder theorem, which, okay, you write the title below. Remainder theorem. Okay, alright, so the factor and remainder theorem saying that if, okay, if you can see that in general, okay, if a polynomial of a degree n, now it's the degree of 3 lah, okay, when it's divided by some linear equation, which is, for this case is x plus 1, we're going to focus on the left hand side. Okay, the quotient is a polynomial degree of 2. Okay, it's always 1 degree lower. Okay, and then the remainder is a constant. For now it's 0. Okay, so what I can explain is currently we can say that x plus 1 ni, when clear ni kan, x plus 1 ni is our factor. Why? Because our remainder is 0. Okay, so we can see that x plus 1 is a factor. Okay, because remainder is 0. So you can check lah. We can check question. Some question would ask something like this lah. Find the remainder. Find the remainder. Okay, I do a sample question. Sample question. Okay. Find the remainder. The remainder when the polynomial x cubed 2x squared, x cubed plus 2x squared minus x minus 2 is divided with x plus 1. Okay, we can prove by doing the remainder theorem. Okay, remainder theorem. Okay, now I'm going to plug in x equals to negative 1. Okay, how do we know x equals to negative 1? We're going to refer to your divider. Okay, so your divider is x plus 1. Okay, x plus 1. So by using the remainder theorem, okay, x is now negative 1. Okay, macam nak buat, you just equate to 0 and then we'll get x is negative 1. Okay, so you're just going to plug in your x equals to negative 1 to your polynomial. Now it become px. Let's say lah, let's say. Okay, 2x squared minus x minus 2 kan. Okay, you're just going to plug in negative 1, substitute the value into the equation. Okay, now if you calculate, you will get 0. So we can say that x minus 1 is a factor. Okay, factor. Alright, now very short kan, compared to the long division kan. So lengthy and tedious method. Okay, alright. So similarly, if on the right hand side we can see that there's some value of remainder 6, which is 6, and when the polynomial is divided by x plus 5, okay, then we can see that our divider x plus 5 is not a factor. It's not a factor. Okay, so we can use the same method. Okay, let's say sample question number 2. Find the remainder when the polynomial x cubed plus 8x squared plus 17x plus 16 is divided by x plus 5. Okay, so sekarang do the same method. You're going to plug in your x. So now your x is negative 5. Okay, so p negative 5 x, I just substitute terus negative 5 into your x. Okay, so negative 5 cube plus 8 negative 5 squared plus 17 times negative 5 plus 16. Okay, careful of the negative sign. Okay, if negative 5 cube, okay, you will get negative 1 to 5. Okay, please be careful of the cube and squared. Okay, make sure to plug in your calculator. You're going to include the bracket. Okay, include the bracket in your calculation. Okay, now you're going to get 6. Okay, 6. See, very short. Okay, this is what as remainder and factor theorem. Okay, so long story short, we can say that the divider is a factor if after we plug in, the remainder would be 0. If the remainder is 0 lah. Okay, but if you want to do the long way, you can do long division. After you divide with the polynomial, you will get remainder of 0. Okay, and then there comes the factor and remainder theorem, which says that if you plug in the x equals to negative 1, which is the factor, if it's a factor kan, then you're going to get a 0. Okay, if after you substitute the value of x, you get some value, then you can say that the divider is not a factor. Okay.